There are few experiments we can use to physically distinguish between two solutions and decide which one is strong, which one is weak. For example, if you have a solution that is containing nitric acid, by definition it's dissociating fully, so it will give you 100% of ions. If the other solution is weak, like ethanoic acid, is going to have partial dissociation. It stays as molecule, 95% of it, and portion of it becomes ions of ethanoate and ions of hydronium or hydrogen. So the first experiment you can do is conductivity. If it's strong, if you connect a light bulb to a battery and dip it into the solutions, it's going to give you high intensity of light. And if it's weak, it's going to have low intensity because you don't have much ions, mobile ions, to carry your electrons for you. So conductivity is one experiment to remember. The other one is the reactions of acids with either metals or carbonates. If it's strong, for example, nitric acid and calcium carbonate, the reaction is rather fast and violent. You produce lots of bubbles of carbon dioxide and the reaction is instantaneous, very quick. If it's ethanoic acid, on the other hand, in comparison, the reaction is very slow and you will get bubbles at a slower rate of time. The last thing to do, and you have to be very careful with this, is pH can be used, but only if they are equal concentration. If the concentration is not equal, you cannot make the comparison. For example, if you have 1 mole per decimeter cube hydrochloric acid, the pH is 0. But if you have 1 mole per decimeter cube of ethanoic acid, CH3COOH, and if you put a pH probe through it, you will get pH of 2.8 in that neighborhood. So pH is a gauge. The weaker acid has higher pH, but you have to remember it's equal concentration. If concentrations are not equal, pH cannot be used to talk about the strength of acids and as a comparison.